Good afternoon from NASA's Goddard Space Flight Center in Greenbelt, Maryland. Welcome to the Engage session. My name is Dina Trask. I'm with the Office of Communications, and again, this is the Engage session. Engage was started as a way to share with the people at Goddard the work being done at Goddard. We find that the people who work here are the best ambassadors of what we're doing. So the more you know about the work that we're doing at Goddard, the better it is for everybody involved. Today's session of Engage is on the Joint Polar Satellite System, JPSS. And JPSS is another example of our partnership with NOAA, and it's an important part of the nation's Earth Science program. Especially excited because JPSS 2 launches next month, and we'll learn more about that and about the program itself from the people who are actually working it. So with no further ado, I'm going to turn this over to Michelle Birdsall, who's going to moderate for us today, and ask her to introduce herself. Thank you.
Good afternoon, everybody, and thank you for joining today. My name is Michelle Birdsall, and I'm the communications team lead for the Joint Polar Satellite System program. And as Dina mentioned, JPSS is a collaborative effort between NOAA and NASA. NOAA funds and manages the JPSS program operations and data products. And on behalf of NOAA, NASA develops and builds the instruments and spacecraft and launches the satellites, which NOAA then operates. NASA developed the ground system, which NOAA operates and maintains. So we're going to do a deep dive into that today. And how many of you checked the weather on your smartphone before coming out today? Yes? Well, 85% of the data that goes into the modeling for those weather products on your smartphone come from weather satellites like JPSS. And we have a mixture here of NOAA and NASA employees. I'm going to have each of them introduce themselves, starting with Tim Walsh, who is the NOAA JPSS Program Director. Tim,
Great.
If you would please take it away.
Absolutely, and thank you, Michelle, and welcome to all those that are here and joining us virtually. It's really exciting time to be a part of JPSS. We're just 12 days from launch. My brief intro to myself is I started here at Goddard in 1991 as a contractor, and I worked on a program called GOES. GOES is, of course, the geosynchronous brother or sister program to JPSS, and after working in the world of guidance, navigation, and control on that program, went over to NOAA in the mid-90s, and I've been there ever since working with NASA on NASA-NOAA joint projects. And so it was a real pleasure for me to come over in January of this year to be the director of JPSS. And so I'm looking forward to launch.
Thank you, Tim. And next, I'm going to turn it over to Andre Dress, who is the JPSS Program Flight Director, and he has been a long colleague of Tim Walsh's. So, Andre, if you would please introduce yourself.
Yeah, so my name is Andre Dress. So, minor correction, the JPSS Flight Project Manager.
Oh, sorry. Sorry, Andre.
So, anyways, yeah, so interestingly enough, I've been here on center since 1987. I started as a contractor working for a little-known company called Ford Aerospace that doesn't exist anymore. Worked my way up working on the Landsat mission for a few years. And then, actually, Tim and I, truth be told, worked together on the GOES mission for quite a while, sitting side by side on console, doing operations together. And then, in fact, I did work for NOAA for about 5 years before I came to become a civil servant at NASA. And of course, continuing to work on GOES NONP, and then worked on the PACE mission, which is still being planned here and developed here at Goddard, and then recently assigned to JPSS, where we're getting ready for launch.
Thank you, Andre.
Thank you.
And we're going to next hear from Ed Kim, who is our JPSS ATMS instrument scientist. He's not just the ATMS instrument scientist for JPSS, but for overall at Goddard. So, Ed, would you please introduce yourself?
Yeah, thank you, and welcome to everybody who's joining us. It's really exciting to be so close to launch. My background is as a microwave sensor person. I trained as an electrical engineer, and during my time at school we built sensors, used them in field experiments, and I joined Goddard straight out of grad school in 1999. I was lucky enough to find a position here that allowed me to work on very similar kinds of things that I had done, working on developing sensors, getting them on NASA aircraft, for example, to deploy for aircraft campaigns, joining some ground-based campaigns for various missions. And then in about 2005, joined well, at that time was the InPost program, but now JPSS as joining the science folks working on the microwave sounder, the Advanced Technology Microwave Sounder, or ATMS. And since then, we've been helping NASA and NOAA make sure the ATMS instruments are working properly before launch, after launch, and throughout their lifetime. And we're looking forward to, and when I say we, I'm referring to the broader science team. It's got representatives from both NASA and NOAA, academia, FFRDCs, and we help make sure that the instrument's working properly and kind of keep eyes on it throughout the mission lifetime.
Well, thank you, Ed. And with that, I'd like to dive right into helping the audience understand why JPSS satellites are so important to our weather forecast. And tell us a little bit more about that, Tim, how the JPSS weather satellites work in conjunction with our other weather satellites.
Actually, I'll say just on Tuesday of this week, I joined a group of people from NOAA and NASA over at the Sterling National Weather Service Regional Forecast Center, and I got to see in real time how people were using our data to basically forecast 3 to 5 to 7 days ahead. It's a great, what we do here on JPSS is a great complement to what people do work on the geostationary or GOES satellites. They look at the Earth from the equator, from 22,500 miles up, and we look at the Earth from 512 miles up, circling the poles. Together, we get like a really fully global view of the Earth, and by measuring those observations globally, we can really do a great job locally with the weather forecasts. And so I really want to reemphasize what you mentioned earlier, that 85% of the data that goes into the models that gives us the forecasts that we rely on today, whether you're looking at the phone, is coming from satellites like JPSS.
Thank you. And now we mentioned that we're launching JPSS 2. It's actually launching on November 1st. And that is a part of a series of 5 satellites. And while all the instruments on JPSS 2 are nearly identical to the ones flying on its predecessor satellites, NOAA 20 and Suomi MPP, can you tell us a little bit about why it's so important to have a series of similar satellites like this?
Certainly. We started SNPP was launched in 2011. As Ed pointed out, it was a long effort with development that led to that launch. And that was the first satellite in the JPSS series. And if you look at all 3, or I should say all 5 of the satellites, including JPSS 1, which is in orbit, NOAA 20 at present, and then 2, which we're going to launch in 12 days, and 3 and 4, which we're going to launch in 27 and 32, I should say. That will give us a continuous record of data all the way out through 2038, or much likely longer than that. And so we're looking at, it's really important for our users, both from a climate perspective and from a weather perspective, is to have highly well-known instruments that are highly calibrated instruments on orbit.
Thanks, Tim. And I'd like to dive in now a little bit more about the satellite and the instruments themselves. Andre, would you tell us about where the satellite is right now and what has to happen in the next week and a half before launch?
Right, so it's actually a very exciting time. We just completed a very comprehensive test program, at the factory at Northrop Grumman in Gilbert, Arizona. Shipped it out to the launch base, and on August the 18th, it showed up on the 19th. I was there for that to see it. And then there's a test program and closeouts and fueling and things like that have to take place to get us where we are today. So just this week, we took the observatory inside the encapsulated fairing out to the launch pad yesterday, lifted it up onto the launch pad, and it's I can say now it's on the top of the rocket. Just last night, we powered up the observatory, and they're doing some additional testing. There's a few more closeouts that will take place next week, but after that, we're ready to go.
And there was very extensive testing over the summer to get us to this point. Can you tell us a little bit about the thermal vacuum testing that took place over the summer?
Yeah, so really the testing there's a whole environmental test program that takes place, and it's not just thermal vac, but it's dynamics, EMI, electromagnetic interface, all these interferences, all these things that have to do to make sure that the satellite will survive in the environment. And one of those biggest tests that we do is, in fact, a thermal vac test, where we take the entire observatory, which has the instruments mounted on it. Inside the chamber, we pull all the air out of it, put it in vacuum, and then cycle the heat, the same temperatures that it will see in environment in space, and try to mimic that environment as close as we can of what the observatory will actually see, and test it and demonstrate its performance in that environment, in this big chamber. And all that testing was done out at Gilbert. We finished it up just in June timeframe, and in time for us to ship.
Wonderful. Now, before we could get to shipping, can you tell us where all the instruments came from to be integrated together at that Northrop Grumman facility?
Yeah, so so all across the country. So there's 4 instruments, and so ATMS, which is Northrop Grumman, that's out in the LA area. VIRS, which is also out in the LA area. The CRIS instrument, which is in Fort Wayne, Indiana. And then the last one is the OMPS instrument, which is in Boulder, Colorado. So all those instruments and their follow-ons are being integrated in those facilities, then have to be shipped to Gilbert to be integrated. Very large team that has to be put in place to integrate, test, and follow it all the way through the launch.
And all of these instruments come together to provide us with the data that the satellite will collect once it's in orbit. And Ed, would you tell us a little bit about how these instruments work together, and particularly ATMS? What does ATMS do, and why is that important on the satellite?
Sure. So the 4 instruments that Andre just mentioned, the VIRS instrument provides the images that most people are probably most familiar with when you see a weather image on the news or the internet or whatever. Provides the visible images. You've seen hurricanes, from space. The typical image you see on the news, the typical weather image is from a sensor like the VIRS sensor. The CRIS sensor is sort of the infrared brother to ATMS, where ATMS is the microwave sounder and CRIS is the infrared sounder. And both of those together provide a 3-dimensional picture of the state of the Earth's atmosphere for our weather forecasting customers. And so the sounding for both of those instruments refers to the fact that they can look vertically down into the atmosphere, whereas, for example, the visible images that we're most familiar with, they gave you a great view of sort of the top of the atmosphere, but if there are clouds, visible light doesn't allow you to look down and see what's underneath the clouds, whereas the infrared and especially the microwave sensor have the ability to see down into the atmosphere. The microwave sensor in particular has the ability to see through clouds, and so for example, for hurricane forecasting, that's really important. You want to see what the conditions are within the vertical structure of the atmosphere, and that really allows the forecast to be more accurate. So all these sensors work together. The OMPS sensor provides information about ozone, and I understand it's ozone hole season, so the OMPS instrument provides that important picture of what the state of the ozone hole within the overall within the Earth's overall weather system. So they really, each instrument has unique capabilities, and altogether they help provide our weather forecasting customers the information they need in 3 dimensions to produce the most accurate forecast they can.
I know one thing that my family checks on a regular basis is the UV index, and that's thanks to OMPS, correct?
That's right.
Are there any other surprising things that people benefit from JPSS data that we might not have realized?
Well, NOAA produces a whole range of forecast-related products. It's not just, the typical weather forecast. There's hurricane forecasts. They look at dust blooms. The data are used by people to predict droughts and floods and all sorts of different extreme conditions. people may remember over the past year there were some atmospheric rivers that hit the west coast that resulted in landslides and sections of the highways, being washed out. Those are examples of things that can be maybe either specifically forecasted or at least the conditions that are likely to produce those sorts of extreme events can be forecast using the data from any moisture-related information. ATMS really is a good source of that type of information.
Thank you, Ed. Tim, do you want to add anything about how the satellite can help with climate monitoring and what we might use it for climate change information?
Absolutely. I do want to go back, if I might, to go to something Andre said. And the test campaign is pretty exhaustive and tremendous, and a great description by Andre. But I came from the operations world here at Goddard, and so did Andre. We started out flying and launching satellites. And I would say that JPSS, I think we had the opportunity to command the satellite from the NSOF facility where we fly the satellites in Suitland, Maryland, all the way to Gilbert, Arizona to the high bay, I think over 400 hours of operation. So I want to emphasize that, especially if you're a young person here at Goddard, operations is the best way, one of the best ways to really put your fingers on the pulse of the satellite and find out what makes it tick and helps you develop better spacecraft and better instruments. So a shout out to the ops people. We appreciate the teams both here and the teams at NOAA that are going to take them from us and when we hand them over about 90 days after launch. One other thing I want to mention that Ed pointed out some of the really valuable applications of the VIIRS data and other data, but wildfires recently has been in the forefront nationwide, and particularly in California where we're going to launch, there have been a lot of tremendous forest fires up and down the coast. I remember when I first came to JPSS in 2018, there was a big fire in Napa Valley, and it really impacted a lot of the vineyards there. And so I've gotten a chance to see how the smoke and other, outcomes from the fire, both in watching the progression of the fire using the VIIRS 375 meter resolution information, all the way to the smoke and particulates going across the country. To me, that was a real eye-opener. Now to go back to your point, so how we use the data for climate is, I mentioned earlier how these instruments are really high resolution, highly accurate instruments, and they have the ability, we work with NOAA to calibrate and keep these instruments calibrated on orbit, and working from satellite to satellite, platform to platform, we can get data that you can easily have a long-term data record that can be used for climate, and that's so valuable to our users. So there's both the near-term need for weather forecasting and then the long-term climate need, which is really valuable when you're looking at whether it's vegetation, droughts, and other conditions that we may be worried about.
And speaking about how we work with NOAA here at Goddard, can you talk a little bit about the ground stations and how that all factors in, and just give people an idea of how NOAA and NASA operate the different facilities that go into JPSS?
Yes, certainly. NOAA does operate the ground systems. Actually, our ground system project, our ground project here at JPSS, developed and supported systems at Svalbard, which is an island north of Russia. It's actually part of Norway, but north of Norway. And it's about as high as you could go and still be on an island to the North Pole. And so we can see all 14 orbits from that ground station. It's super valuable. And then correspondingly, we have a southern hemispheric coverage at McMurdo Station, which is a U.S. station on the South Pole, Antarctica. Not necessarily at the South Pole, but close enough where we could, again, see all 14 orbits. Those two sites are nearly unique in that we can get every bit of half-orbit data from each satellite accordingly when we get J2 up there. And so it gives us a lot of latency. Latency is basically if we reduce the time latency, we can get the data to the models quicker and make the models that much more timely. So that's our goal.
And
I should mention, too, that we do fly these satellites down at NSOF. It's the NOAA Satellite Operations Facility in Suitland, Maryland. That is an incredible facility. If you haven't gone to visit it, that's where we fly. We NOAA fly satellites that were mostly handed over from NASA. There's about 16 or so at any given time. And that's where we get the data we consolidate the data and move it out to our users. Mostly the National Weather Service, but really a wide variety of users from there on.
And we're producing a lot of video products right now, getting ready for launch. And one of those video packages is about the NOAA Satellite Operations Facility, or NSOF. And so you get an inside look at the facility, and you see all of the employees getting ready for launch. They were doing a mission rehearsal on the day that that was filmed. So you can access that through the JPSS 2 launch page very soon. I highly recommend you check it out so you can see firsthand what that facility looks like. Now, you mentioned launching out of California. Can you tell us a little bit more why it has to launch out of California in the middle of the night? And then, Andre, if you'll piggyback on that as far as what we can expect on the day of launch, what that looks like, and what those watching on TV will see?
Sure.
Sure. I'll start by Vandenberg's unique in that it's in almost a peninsula that juts out into the Pacific Ocean, and we could launch south. And so most of the launches from Vandenberg go south. And so we launch into a unique orbit it's a polar orbit, but sun synchronous, which means that from the solar perspective, the satellite is always in the same position at any given time. And so the reason why we call the local time of ascending node is 13:30 or 1:30 p.m. And so we launch in the morning so that when we rise on the other side of the Earth to the equator, that it's exactly 1:30 eventually when we finish all our orbit raising maneuvers. So that's the really key thing. And so we have for our users, they get the same sun angle for all the products at any given time. And we work with our partners in Europe to get other angles, so to speak, to complement our models.
Right. Yeah. So I mean, there's an inherent advantage, of course, from launching from Vandenberg because you're at the higher latitude and it's more efficient for fuel-wise and stuff for launch vehicles and payload size and stuff to actually get into that polar orbit. So yes, it's going to be launching early in the morning, which for us is not the greatest thing. To be there at 2:30 in the morning, and we'll have to be on console hours before that. Having spent the better part of the last month in Vandenberg and just being there, it's a very interesting place, very beautiful, right by the ocean. But the one thing I've observed is that it's always foggy there. So I'm hopeful that we have a clear day on the day of launch, so that when we actually launch, that people that are coming out, flying all the way out there to see it, will be actually able to see it before it goes into the clouds. And I know there's several sites that you and your team have had lined up for the people to come and watch. And then after launch and separation, as Tim mentioned, we go into that orbit. There's a certain sequence of events that will take place after launch. There's a wake-up call that goes to the satellite, and then once it's separated, things really start happening at that point. We start turning on transmitters and communicating with the ground, and that data is going to go to the NSOF, as Tim mentioned earlier, and so they'll be able to see that event, and then the solar rays will be deployed, and and getting it in the right attitude and the right orbit is all a part of that first hour total time of sequence after launch. So it's an exciting period. Of course, for the people on the ground, you won't see that. But know that the people at the NSOF are seeing it and commanding and are in control.
Then another exciting milestone after that is, I've been told it's like baby pictures that we get in December when they first turn on the instruments and it starts sending back data, that those are what we call the first light images. And they will then calibrate and test. And Ed, maybe you can talk a little bit more about that process, how they make sure that the instruments are sending back accurate data and then start to work within the constellation that will include Suomi SNPP and NOAA 20.
Yeah, sure. So each of the instruments, after they're turned on, goes through a checkout. There's some similarities between them, but then, of course, since each instrument has its own unique aspects, there's some unique aspects to it, to the turn-on sequence as well. And then, at some point, enough of the instrument is on that you can actually generate an image, and that's the first light image that you referred to, Michelle. And so, for example, I'm most familiar with the ATMS instruments, and that's the one that I work on. And for various reasons, ATMS is sort of reaches that fully turned on state earlier than the other instruments. So the ATMS image is usually the first light image of the first light images from each of the satellites. And in fact, because that's the case, the first light image for the entire JPSS program is an ATMS image. So it's exciting. We work for months, before launch to go over the exact sequence of what has to happen. Which calibration-related things are we checking? ATMS includes a scanner, so there's a rotating part that basically rotates the entire mission lifetime. That has to get checked out. There are 22 channels. We look at each individual channel. We know, based on the pre-launch ground-based measurements, we know how each one should behave, what the data should look like, how noisy they should be, how accurate they should be, and we double check that on orbit, compare that to the pre-launch measurements, make sure everything looks okay. We work with our NOAA colleagues. They take some of that early data, actually feed it into the weather forecast models to see how that data is being used by the models and adding to or improving the accuracy of the forecast. So it's an entire process, but it's if you work in this field, this is launch, and that the first 3 months following launch is the commissioning period. That's probably the most exciting period for the instrument teams.
Thank you, Ed. And that sparks a question in my mind. How does one get to be an instrument scientist here at Goddard?
I don't know about the other instrument scientists, but in my case it was mostly by chance. My background was sort of traditional electrical engineering in school. I happened to work on building instruments as part of my school experience, and didn't really know what to expect when I arrived at Goddard. In fact, I was in a program where we also sort of cross-trained, if you will, to be more pure scientists. So it wasn't just engineers who knew how to build instruments, but scientists who also knew how the data from those instruments could be used. So originally I was supposed to just do the pure science part, but right before I arrived, a position opened up in what was at that time called the microwave sensors branch, which was housed in the science part of Goddard rather than the engineering part of Goddard. But all the folks in that branch sort of had this instrument background in addition to the science background. And so in some ways we were like the interpreters or the translators. We could understand what the scientists wanted and how they used the data, but at the same time we understood enough of the sensors. We could talk to the engineers. We could help them figure out what requirements were on the engineering side. Right now, for example, we're working on helping NOAA plan for the follow-on to JPSS, because they need to plan in advance. So we're using our expertise in both on the instrument side as well as the science side, and talking a lot with our weather forecasting colleagues to come up with requirements for future sensors that the U.S. and the international weather forecasting agencies are going to rely on through probably the year 2050 or thereabouts.
And that's a great segue, because first off, the fact that you started as an electrical engineer, so did you, Tim, correct? Yep. And it's always interesting to be able to tell the stories of the people at Goddard, how they got to where they're going. And that helps everyone map out their career here. And I know it inspires a lot of the interns that we get on the JPSS program. So Tim, maybe you can talk about the opportunities within JPSS and what the future is going to hold with those follow-on programs.
Sure. First of all, with interns, it's one of my favorite parts about working here at Goddard. I mean, when I first started at JPSS, we had, I think, the first summer, 20 interns. And that was a very healthy program. And I think from a U.S. taxpayer perspective, we get the best bang for the buck from these students that work for us. They are really brilliant, they're smart, and they work their tails off, so to speak. But we traditionally have moved them into a number of different areas. Like I said earlier, one of the best ways to get to know spacecraft is to fly them. And so some of them will move into the world of operations. Some will move into the world of new instrument development at JPSS. What we're rebranding ourselves as is another program called the LEO Earth Observation System. or LEOS, or I should say LEOS. And so we're using LEOS to develop the next generation of instruments that Ed was referring to that will follow JPSS. And probabilistically, we need to follow JPSS by no later than 2034. So we have to start building now. And in fact, just yesterday, we released our first request for information for our next generation instrument that will follow the ATMS. And we're very excited about that. But again, students will go over the whole spectrum of where they can be. They can be working for you in comms. They could be working for operations teams and sometimes instrument and spacecraft development.
Absolutely. And
I should also say ground systems too. Yeah, we have a large ground system that has a really thorough amount, it covers a tremendous amount of functions. In fact, it's a LEO enterprise ground system, and we need people there's so much software that needs to be maintained, developed, and things tested as well.
Yeah, we had several interns working on the ground system this past summer, and that's always a highlight, their tour of the NOAA Satellite Operations Facility. Yep. Andre, can you talk a little bit about your career path and what you see in the future for JPSS and beyond?
Yeah, absolutely. Am I on?
Oh.
Here.
There you go.
Okay. Yeah, so I'll also mention here at Goddard, there's a lot of aspects to a mission, right? So there's the engineering, there's science, there's financial, there's schedules, so there's a lot of things that go on here at Center, and so it's not always just technical people coming here to learn. There's financial people and things like that that are interested in that aspect of a mission also. And I'll also say, like, for the instrument scientist, it's an important job, especially early on in the formulation of a mission, right, where you're trying to determine what is achievable, what's affordable, and what the needs and expectations are, right? So that marrying of management and technical and science together to determine what actually is achievable in reality takes a lot of coordination and a lot of discussions, that I call it the healthy tension of project management. For myself, as I think I mentioned earlier, I started off in operations, much like Tim, working here on Center over in Building 28 when they did operations there on the Landsat, and then went to work in operations on GOES. And in fact, I actually remember the day that I met Tim. It was not the NSOF, it was FOB number 4.
The predecessor.
So the old buildings, I think, that were built during the war, and they were used as hospitals, and they got turned into operations control centers. And I was walking down the hallway with Charlie Bankston. I know Tim and I are friends with him still, and he was like, we saw Tim walking down the hallway, and he's like, let me introduce you to Tim. And so that was 1992, right?
Right.
So quite a while ago. All truth be told, Tim and I are very good friends. I was at his wedding. We've seen our kids grow up together, so I'm happy to be here. I was fortunate, though, in that, working in the operations and then also getting an opportunity really to come back to GOES here at NASA, working as an observatory manager, right? And then, understanding how the programs work and really getting involved into the day-to-day operations on the technical build side. And I think having that operations knowledge and understanding helps people, on the engineering technical side is, again, what is achievable and what's, actually can be operated in orbit, what things are important to that team. Made my way into deputy project manager and then ultimately project manager here. So I've been a project manager on several missions, both in-house builds here as well as out of house, and I enjoy them all. So I'm really looking forward to this, and I'm happy to be back working with Tim and this team.
a very exciting time. And yes, and there are so many resources available to you on the NOAA.NESDIS.gov website where you can find the JPSS-2 launch page. You can also find all of the JPSS program information there. We do hope that you will tune in for our launch. The launch broadcast will start at 4:45 a.m. Eastern Daylight Savings Time on November 1st. So it will be a very early morning, but it will be a very exciting broadcast to watch. And before we get into the Q&A period, I just wanted to see if there were any other go-backs of items that you wanted to share with the audience today.
Well, I'd like to actually pick up on what Andre mentioned, but maybe from the science perspective. That I remember early early when I first joined Goddard, talking to the other scientists who had been around for a while, and hearing something like, as a scientist, if you get a chance to work on maybe one, possibly two missions during your career here, that's about what you could expect, because each one would take a certain amount of time. And especially in the earth sciences is so broad. In your particular science area, there may only be one or two missions over the span of your career. But I found that as a result of ending up, as I said, kind of by chance, working on what's actually more of an operational mission. Most NASA missions are not, the operational kind. They're research missions. They're one-offs. And but I've found that, and I do work on other missions at Goddard in addition to just the JPSS work. And I found that the experience that I got from working on JPSS has enormously helped my understanding of just the process of developing missions, all the way from the napkin sketch stage to, launch and post-launch checking out. So I would encourage, anybody who's in sciences to look for opportunities to get involved, not just in the traditional NASA research missions, but also, if there's opportunities to get involved in something like JPSS on the more operation, because you see more missions, right? It's not just a one-off program, and just like anything else, when you see different versions of something, it gives you a broader perspective, and really helps with, as I said, each stage of mission development. So every mission that you work on is going to have very similar stages of development. And any experience that you can get from working on different types of missions really helps you out.
Michelle, if I may, I really like what Ed mentioned there, but the fundamentally JPSS, while operational, we're all about science. And so the unique thing about working on one of these NASA NOAA missions is some of the world's best instrument scientists are right here at Goddard. And yet we also have to interface with those operational users and the scientists on the NOAA side that have to kind of figure out all those requirements that Andre was referring to. And then people like Andre and I take all those requirements, put them in a big pot, stir them up, and figure out what's affordable and executable. And then we plan the program accordingly. So I love the fact that we're fundamentally based in science. And the two science communities, as I've grown through my career and gone out of the engineering world and into the program management world, is probably the biggest positive for me, is just interacting with those very, very cooperative but somewhat different communities in the science world.
Yes, and I'll follow up with one thing. I mean, there was three of us standing here today, but to develop a system like JPSS in any mission, there's literally thousands of people that are behind us that have spent many, many years, the better part of a decade, to actually get to this point. And so I want to make sure that we're recognizing all those people for all the hard work and dedication that they've spent. Time away from families, on travel, late hours in the night. It takes an army, and that army is, pushed a lot of times to do things to get us to this point. And so I want to say thanks to all those people.
Yeah, absolutely.
Yes, thank you.
And I don't say that just from the people here at NASA. I mean, all our partners, the instrument vendors, spacecraft, launch vehicle, everything. So.
And it really is a round-the-clock operation, right?
It is,
I mean,
yes.
all the testing and work that went on over the summer and at the operations center, it doesn't turn off.
Right.
Yeah, time never stops. Yes, you're right.
Well, thank you all. I hope that we have prompted some great questions from the audience, and I think we're just about at time for that, getting close to that, but I'll put one more plug in for checking out the NOAA.NESDIS.gov website, because as Andre mentioned, there are so many people that have been involved with this, and a lot of the video packages that you will see for the JPSS-2 launch highlights many of those individuals. You'll see many of them highlighted on the launch broadcast, the NASA Edge rollout show, at the different media briefings. There's a lot of events happening in Lompoc, California, near where Vandenberg Space Force Base is, where the launch is taking place. So we will have an opportunity to spotlight so many of the hardworking engineers, scientists, and other professionals that have put all of their effort into this launch. We'll be out talking to schools. They will be out in the community. So for those of you who are local, I know since we're online, we may have folks out in California listening today. Please be sure to check out all the wonderful events we have going on to support this launch, and it will really give you a good understanding of the day-to-day benefits that the JPSS program provides to each and every one of us. So with that, I'll turn it to you, Dina, for the Q&A.
Thanks, Michelle. Okay, let's start off with, first of all, thank you. Thank you very much for speaking with us today. So let's ask a few questions. Andre, you mentioned about the thousands of people who work on the project. What contractors are employed on JPSS?
So it's a big question, right? And there are a lot of contractors, and so that's a very broad question from the perspective of looking at the entire mission. So there's contractors here on the center. There's contractors that provide instruments. There's contractors that provide spacecraft, and so I'll walk through the major elements, because I suspect that's the question that's really where it's coming from. So the spacecraft is built by Northrop Grumman, and that's in Gilbert. We also have an instrument that's built by Northrop Grumman that's out in the LA. That's the ATMS instrument that is the lead on. And then we have the VIIRS instrument, which is built by Raytheon. That's out in the LA area. We have the OMPS instrument, which is built by Ball Aerospace out in Boulder. And then the CRIS instrument, which is built by L3 Harris, and that's in Fort Wayne, Indiana.
So where are all those instruments integrated into the spacecraft?
So all the instruments, they collectively show up, and they show up at Gilbert. And, one at a time, we bring them in. There's a large review process, and in fact, we're going through that process right now for the follow-on mission, which is JPSS 3, where there's a review going on as we speak. So while we're launching one, we are actually preparing to integrate instruments on the next one. So there's a review process we go through, making sure that we have all the logistics as far as things that need to be there in order to test the instrument when it shows up at Gilbert in Arizona. And so each one will show up, and it'll show up with a team, and it'll be checked out, and then it'll be integrated onto the spacecraft. The next one will come in, and it's not necessarily serial. A lot of these things are happening at the same time.
Right.
Dina, if I may, I also want to add that the ground system is a large component of JPSS. And Raytheon out in Colorado is the prime contractor there, but a lot of their people are here supporting both the system development in the local Goddard area and also down at Suitland.
Oh, great. Right, a question came about the partnership between NASA and NOAA. How does that work?
Yes. Well, let me first start by saying the first weather satellite was launched by NASA in 1960. So 62 years ago, and NOAA came into being in 1970, and since then NASA and NOAA have been, NOAA brings the requirements to the table, the operational know-how, and then they actually fly the spacecraft after we launch and hand them over. Goddard is really here because it was a perfect relationship, to be honest. I mean, all the we hear the instrument scientists, the engineers that are familiar with building and launching and testing spacecraft, and the program management people like Andre who've done it before, right? And they know where the pitfalls are of building a satellite. So I have grown up both on the NASA and NOAA side. I see that integration it's so valuable and see it lasting a significant amount of time as we develop that next generation system.
It sounds like a partnership that uses the best qualities of each organization.
Absolutely, yeah.
Question came about how long will JPSS operate? What's the lifespan of JPSS 1, or which is now called NOAA 21?
There's I'll speak to it real quickly. So we design them for a certain period, and that design which we're going for and that length has a lot of factors that go into it, right? The test environment, how much redundancy and things like that go into it. So the longer you want it to last, the more money it costs, right? Because there's more testing and more redundancy that needs to be built into it. So for this mission, it's designed for 7 years, but it also is packed with about 10 years of fuel. And to be honest, if you look back at NPP and JPSS-1 and the other missions, we design them really well and build them really well, and they typically last much longer than the periods that we are designed for.
That's good, just in case. Someone asked a question about watching the launch in person.
Yes, we had a couple months ago, there was invitations that went out to the larger public and to people on JPSS and here at Goddard. There's, I want to say 1,400 people that will be in person at Vandenberg in the middle of the night. And so I'm really impressed with the amount of people in this post-pandemic world. I think the last NOAA-NASA launch was GOES-T back in March, and I don't know how many people were able to come to that, but I think we're the first one that's really fully post-pandemic, and so I'm very excited about that. And I'm excited about the enthusiasm that people are showing for a middle-of-the-night launch.
Yeah, I mean, you could go there, right? You don't necessarily need to be invited. You could go there and still be pretty close to where the launch pad is and not be on the base and watch it. And one other thing I don't think we brought up, but this is the last Atlas V that will be launched from the West Coast.
Oh.
So it's a significant event from ULA's perspective, United Launch Alliance, and LSP, Launch Services Program, NASA, that this will be the last Atlas V from the West Coast.
Yeah.
That's exciting.
A tremendous milestone. As soon as we get off the pad, they'll start to refurb it for their next generation launch vehicle.
Great. I also think that if you go to the Vandenberg website, it probably has where you can find local places to watch.
Yeah.
I'm sure it's a wide swath that you can be in and still see it.
Absolutely.
Do we have a question in person?
Thank you. Good afternoon. I'm Nick Scher with Aerospace Mechanical Engineer here at Goddard. And it's orbital type questions I was pondering. I was wondering your spacing of the different JPSs. Do they have how they plane to each other in the orbit? And does one take over the location of another one over time, which I think I've heard with other types of orbits that happens? And the third one would be, what's the plan for end of life when you run out of fuel?
I love that question. It's a good one. And right now we have the two satellites in orbit that are generally carrying the same suite of instruments, SNPP and what we now call NOAA-20, which was JPSS-1. And they're separated by 180 degrees. They're basically on other sides of the same orbit, circling and having the same time with the local time of the sending node. So we're getting a higher refresh rate at the same kind of sun angle, and that's really positive. So what will happen when we launch the newest satellite, J2, is we'll launch it a quarter orbit between the two. And we'll do some cross-calibration, and we'll work it. And then we'll once we determine which of the two primary spacecraft, that's a decision that's made with NOAA back around 90 days after launch. we will start to figure out, we will put the primary and secondary spacecraft 180 degrees or half orbit apart, and then the third spacecraft will be positioned in a quarter orbit therein. Now, there's some question, your point about deorbiting is also something that we're really sensitive to in the right ways. You know, earlier, NOAA used to work with NASA and launch these low Earth orbiting satellites called TIROS or POES, they were called, and they did not have the ability to come back. So they're basically, when they're turned off, they're called passivated. You know, everything is expended as much as we can. But there's always a potential they could be fragmented, whether it's through a self-induced explosion or by hitting another piece of debris. So ever since 2001, roughly, the US has made a commitment to bring back satellites. And so this new satellite, 2011, SNPP has the ability to come back. We have to save a certain amount of fuel to do so. And so Andre's calculations that he was talking about integrate that ability to bring in the satellite. So there's certain conditions that we'll look at. And when the satellite becomes, its health is tenuous enough that we want to bring it back, we'll do so. Because the last thing you want to do is leave something up there with a certain amount of fuel on it that could potentially explode. So great question.
In fact, the bulk of the fuel that's on the spacecraft is just for control reentry. You know, the amount that's needed for just housekeeping, station keeping, things like that is very small compared to what's required to return it into Earth.
And we bring it back in the Pacific Ocean, a point called Point Nemo, which is the middle of nowhere, as far away from populated areas as possible on the Earth. So,
Thank you.
Another question from online, it's from Gary. He was the lead tech writer for the user guide for some of the simulators for JPSS-1. Can you talk about the simulators for JPSS-2 that help prepare operators to make reliable updates on the satellites?
You want me to take it? So part of the process in preparing the team to get ready for launch is it important to have something to test with, right? So it's very expensive to take the spacecraft and take it and just test with it all the time because we have to build it and test it by itself. So for the operations team, we also build a high dynamic simulator that looks just like the real thing, from the operator's perspective, and that's typically built by the spacecraft contractor. In this case, it's Northrop Grumman, and then we integrate instrument models on top of that, and so that it has the look and the feel like the real thing, right? And so we provide that to the operations team, and it's used whenever they need to do rehearsals or develop products like scripts and procedures. And so their day-to-day activities use that simulator quite a bit. So it's a pretty important object, piece of steel, I'll call it, that's used to prepare the team.
Yeah.
It's also important, and I think Tim mentioned it much earlier, that it's important to test with the real thing, the real article also. So we do make the spacecraft available to the operations team also, so as a complement to their readiness.
It does take a lot of people to make this work.
Yes,
absolutely.
There's a lot of aspects to it.
So another question in person?
Yeah, I think Michelle mentioned that the JPSS satellites are similar but not identical. Is there anything about J2 that is unique compared to the other two spacecraft that are already on orbit?
I mean, I don't know if you...
Well, it's got one less instrument for starters.
there's a number of differences. Why don't you start with the science, and then we'll...
So the ones that are on orbit have the Series instrument, which is looking at the entire, sort of the whole radiation that the entire Earth receives from the sun. It's the part of looking at the energy balance from a planetary perspective, mostly for, I think, for climate purposes. And I think we're maybe the best way to say it is we're in a transition to what will be like a follow-on to that Series instrument, but it just happens to that type of instrument is not on board the J2.
There are. Let me just enhance a little bit. So there's the OMPS instrument has the LIM, which was not on the previous mission. So there is that extra element of OMPS, right? And then I think it's also important to point at some things that were done on the spacecraft to enhance. So the downlink, the high rate, the X-band downlink has been increased, I think, from 15 megabits, megasymbols per second to 25, right? So there are enhancements that were done on the spacecraft also to provide more data. I know you scientists love data, right?
Yeah.
So it's always important to get as much down as possible, and so the observatory will provide that.
One thing I'll mention too is, Andre alluded to it, but the satellites SNPP and J1 or NOAA 20 were built by Ball in Boulder, Colorado. And so one of the biggest things that we're doing here is we're changing the actual satellite bus provider. And so it's kind of like launching the first of a kind in a way. So that's,
Right.
I think it'll be
I should probably add that, purely from a science perspective, and especially from a NOAA perspective, thinking operationally now, there's a lot to be said for having the same kind of instruments on all, every satellite in the series. Because especially for long-term purposes like climate studies, you want that consistency of in your data. So not having differences is also important. While also, there are opportunities sometimes in satellite series to add, like maybe a prototype of a future sensor or something like that.
That's a very good point. I had never considered that before, the long-term data. That's a very good point. One final question I'll have for you. Where are you going to watch the launch?
So it's probably different for all three of
It
us.
is,
Right.
yeah.
So I'll go first, and then I'll let them jump in. I will be in a control center at the launch base at Vandenberg, and so I will watch it on a screen. I will hear it and feel it from the control center, because while it's miles away, you still feel the rumble, right? So it's interesting as you're watching it take off, right? And you're seeing it on the screen, and then a little bit of seconds later, all of a sudden you start to hear it and feel it, right? It's an interesting sensation that the speed of light is much faster than the speed of sound, right?
Yeah.
So I will be in the control center.
And I will be in a place called the Hawk's Nest, which is a local observing area. I am much less important for launch than Andre is. And so I will be on NASA TV during the launch, giving some insight, or hopefully some insight. So I'm really looking forward to. I have a feeling that even though we're going to be where we could observe it, that we may be feeling it and hearing it more than seeing it. Right. Just as Andre said, in the middle of the night, there's a lot of fog in that area, so we'll see what happens. Ed?
And I'll be in the DC area at home, and especially given the early morning time of the launch for East Coast folks, I'll be watching it on the computer from home. I have on a different mission. I have been in person at Vandenberg watching a launch, and I highly encourage anybody, if you've never seen one, to get out there. Especially if the weather cooperates and you don't have the clouds. The nighttime launch is spectacular.
Yeah.
A lot of people have. I think was it the JPSS 1 launch? Was it absolutely beautiful? I unfortunately I couldn't be there in person, but I have a photograph of that hanging in my office, because that was one where there were no clouds and you could see the trail. And it was beautiful.
Well, fortunately, you have lots of opportunities to see launches. There is the JPSS launch on November 5th. No, 1st. I'm sorry, thank you, 1st. November 5th is the Antares launch from Walsh Flight Facility in Virginia. And then November 14th is Artemis 1 launch from KSC. So everyone can have that experience. Thank you very much to our speakers and to Michelle. Thank you very much for joining us today.
Thank you.
Thanks.